Okay, and continuing on with our section 5.1 on example 3, here we've got a little bit more complicated f of x and g of x. They both are fractions. So first thing I want to do is decide what the domain is of each of these. So what we cannot have in the domain of f of x is whatever would make the denominator equal to 0. In that case, it's going to be x. So x cannot equal 5. For g of x, the domain is going to be things that would make the denominator 0. So that would be x cannot equal -1. Those are the only two restrictions for those two functions. And I want to see what f composed with g of x is. So f of g of x. That means I'm taking x and putting it into g. So that just says x plus 1 2 divided by. So now 2 divided by x plus 1 is going to be the input into function f. And function f says you're going to divide 3 by the input, so that's 2 over x plus 1 minus 5. Ooh, that doesn't look so good. Let's see what we can do to simplify this. Okay, first thing I notice is that I've got a fraction minus a whole number. So I've got to get a common denominator, and that denominator needs to be x plus 1. So I'm going to multiply this by x plus 1 over x plus 1. My numerator stays the same, so now I have 2 over x plus 1 minus 5 times x plus 1 over x plus 1. Okay, we're getting closer here. Let's distribute that -5 to both things inside. So I now have 2, and we don't change the denominators when we're subtracting, so that's all going to be over x plus 1. So -5 times x is -5x. -5 times 1 is a -5. Okay, let's go ahead and, again, combine these. So I've got a -5x. 2 minus 5 is a -3. This is still over x plus 1. So I have a whole, oops, there we go. We've got a whole number divided by a fraction. And when we do divide by a fraction, I've got to take the fraction and take the reciprocal of it. So I need to turn it upside down. So turning it upside down is going to be x plus 1 over -5x minus 3. And now we multiply. So I'm going to have 3 times x plus 1. And that 3 is really just 3 over 1. So 1 times -5x minus 3. Let's continue that on down here. So I'm going to have 3 times x plus 1 over a -5x minus 3. Okay, and one last step. Let's distribute the 3. So I've got 3x plus 3 over a -5x minus 3. Okay, that's what we have. So now I want to see, that is f composed with g of x. Remember it right here. We've got that. Now I want to see what is the domain of that. Okay, so I need the domain of g of x, whatever that was. So x cannot equal a -1. But I also need to see for this composed function, what can I not have? So because we're doing division, I need to look at the denominator. And I cannot have x's that would make that equal to 0. So I'm just going to come over here, -5x minus 3. I'm going to set that equal to 0 and solve for x. Whatever I get is what I've got to exclude from the domain. So let's add 3 to both sides and divide by -5. So x cannot equal a -3/5. So x cannot equal -3/5 or -1. Every other number is perfectly okay. Okay, let's try another example. Okay, we've got the same two functions, f of x and g of x, and it wants us now to do f of g. Well, we did that on the previous example. So I'm going to go ahead and just put what this one equals. This equaled 3x plus 3 over a -5x minus 3, and what their domain was. So the domain here was x could not equal -1, x could not equal a -3/5. Okay, and now they want to see f composed with f of x. Okay, so again, remember what was our domain for f? This was x cannot equal a 5. And those are supposed to be the set brackets. So I've got to say f of x, which is 3 over x minus 5. So 3 over x minus 5, I'm now going to turn around and put back into f. So that's going to give me 3 over, here's the input again, minus 5. And once again, I've got a fraction and a whole number, so I've got to multiply the whole number by the denominator over the denominator to try and get that common denominator. So I still have a 3 in the numerator. I have 3 over x minus 5, and I've got a negative 5 times x minus 5 over x minus 5. Okay, let's see if we can clean that up. The numerator is still just a 3. The denominator, I've got 3 over x minus 5. Negative 5 times x is negative 5x. Negative 5 times negative 5 is a positive 25. Oh, we're getting closer here. So negative 5x, 3 plus 25 is 28, and this is over x minus 5. So again, remember this 3 is just a whole number, so that's 3 over 1, divided by negative 5x plus 28 over x minus 5. We're dividing by a fraction, so I've got to take the reciprocal of the fraction, so that means x minus 5 over a negative 5x plus 28. And now I multiply. So 3 times this, so this gives me 3 times x minus 5 over negative 5x plus 28. Sorry, that 5 does not look good. Negative 5x plus 28 is in the denominator. Okay, well, I guess I could distribute that 3. So it'd give me 3x minus 15 over a negative 5x plus 28. That is f composed with f of x. What is the domain of this? So the domain is going to be limited to what the domain was of f of x, which was simply x could not equal positive 5, and whatever value of x would make the denominator equal to 0. So let's just negative 5x plus 28, set that equal to 0, and solve for the x value that I have to exclude from the domain. So subtract 28, and we get negative 5x equals negative 28, divide by negative 5, and I get x equals 28 over 5. So again, that's a value I cannot have. So it cannot equal a positive 5, or it cannot equal 28 over 5. Those are the two values that I cannot have in the domain. Every other number is good. Okay, let's try example 5. Okay, so we're given f of x, we're given g of x. Oh, and we want to see, does f composed with g of x equal g composed with f of x? That has a certain special meaning. So let's do this f of g of x. We want to show that they both equal x. Okay, let's see. So I'm going to take g of x, which is negative 1/2. So I'm going to be plugging negative 1/2 x minus 1 into f. So it's negative, f says take whatever I'm putting in here, multiply it by negative 2, so negative 1/2 x minus 1 plus 1. Okay, let's see what we get here. So negative 2 times negative 1/2 gives me a positive 1. So those really cancel with each other, giving me x minus 1 plus 1, which equals x. Okay, that's good. Okay, now let's do the same thing. G composed with f of x and see what we get. So f of x is just negative 2x plus 1. That's going to be my input into g. So that says, g says negative 1/2 times a negative 2x plus 1 minus 1. And let's multiply this out. The ones cancel.